Juste Raimbault, working as a research fellow, so under supervision of Mike Batty at Center for Advanced Spatial Analysis at UCL. And I will give details on this integration of MATSim into a broader four-step transport model using scientific workflow systems, so both DAFNI and OpenMOLE that we will see later in the second part of the event. So just to explain a bit why we need to do this on the particular MATSim case. The MATSim is itself is just the transportation part of the simulation. So you need to give it some population, so the coordinates, some plans, daily plans for people, and so on. So this has to be done through upstream models. And then you also need downstream models to process MATSim output. So MATSim will just give you this was the trajectory of people during one particular day and so on. So you need really to, for it to be usable, you need to integrate it into a larger framework. And if you go, so Mike mentioned broader urban model. If you go, for example, into land use transport models, these also have a lot of different components and consist in some large coupling of different components for transport, for land use, for activities of agents, for markets, like for example, housing market and so on. So depending on the model, so this is from a review by Wegner. Depending on the model and so on, you need to cover a lot of different heterogeneous components. So in our case, there are very few examples actually of validating or doing sensitivity analysis on MATSim. So the aim of this project was to provide some modular and open implementation of MATSim. And this is quite important for it to be generic on any urban area. So you can test what depends on the geography and what is generic to the MATSim model. And then be able to do some validation and sensitivity analysis method on MATSim. So digging directly into the detail of this integration. So this is a four-step multimodal transport model using only, so it was I wouldn't say a constraint, but a requirement that we wanted to have. So to have only open source models and open source data. So the core, of course, is the MATSim framework for the transport system itself. So it's a Java language, so you can easily package it and run it. Then to create the synthetic population, we use the Spencer model, which was already mentioned by Max. So it's developed at the University of Leeds by the team of Nick Lomax. And this provides some synthetic population distributed in space into MSOA. So MSOA are middle layer areas for census. So it will give you some population with detailed characteristic for each individual and household. So it's based on census to generate this population. Then we also generate some homework commuting plans. And for this, we use, which I also mentioned, the quant model, which was developed by Batty and Richard Milton at CASA. And finally, there is, you will see a bit after, but you have to do a lot of piping and data processing. And for this, we use a specific Scala library called Spatial Data, developed by the OpenMOLE community. So yeah, to give you a bit more context on the data that it included. So first of all, it's generic for any FUA in the UK. So for this, we use a GHSL database, which is a global database of functional urban area. And then we use the census, ordnance survey roads for the transport network, and then for public transport we use a Traveline national dataset. And we integrate all components using two different workflow systems. I will show both later. So the DAFNI facility, which was the subject of the event, and also the OpenMOLE software, which provide some methods, for example, for sensitivity analysis. So yeah, I won't go then into all details of the implementation, but we use OpenStreetMap buildings to distribute the population at the really micro level. So we put people into buildings. Then we use a quant model to have homework flow, and then we sample job location, just by sampling the flows. Then to generate, so the activities we generate are quite simple. It's just home and work, And we've got some simple uniform sampling of start time and end time during the day. And then all of this has to be prepared into specific MATSim XML files, but then you will feed into the MATSim model. And it was also mentioned, but all these models are packaged into a Docker container and then integrated into the workflow system as Docker containers. So this is an illustration of data preprocessing. For example, for the road network, you need to extract your FUA. Sometimes you need to merge the different tiles of a road network and then construct some topological network with simplifying and so on. And also for the public transport, you have to do some step going from a particular format, which is called trans exchange, to GTFS using a R package. And then going to GTFS to my specific MATSim XML schedule using another Java library, which is called PT2MATSim. Okay, we had a bit of context on DAFNI, but a bit less on OpenMOLE. So OpenMOLE is a model expression open source software. It's focused on free access. So the first one is similar to DAFNI model embedding. Second one is also similar to DAFNI, so transparent access to different HPC resources. And the last component is that's why we use it here. It provides you some algorithm for model expression, model validation, and model optimization. So you will have a much more context on the second part of the event on OpenMOLE. And what are the parameters for the MATSim model I study in this particular work, this particular context? So first of all, looking at the importance of the spatial context, I said it, will you have similar results if you run on London or Manchester? So what is due to the geography and what is generic? Then also the impact of stochasticity is quite important. So across different runs, because it's a random stochastic model, if you run it 2 times for the same area, will you have a similar result or totally different? Then we also look at the influence of synthetic population sampling, because of the runtime and memory issue, you have to sample your population. You don't have the full population. And for this, you need to sample. So what is the influence of this parameter? And finally, so the parameters for mode choice, you have some mode constant in the MATSim scoring function, and you can change them. Okay, I will now give a very short illustration of how we integrate the model. So this is first the DAFNI integration. Okay, I will go into the DAFNI platform. So Tom will show you in more detail how it works, but here in the home, you've got some tabs here, and I could go to the model tab. So these are my models. So the user has his own model. And then you can also access models by other users. So these are mine. And if I want to add one, for example, I click add model. And then I will have to provide a YAML file, which is a configuration file, saying what is my model, what are the parameters, and so on. And then a Docker file. So here, if I put the YAML, and then you will have to validate and so on. I don't think I have the Docker file. No, it should be in image there, but when you containerize and package a Docker file, it looks like this. You get a huge tar.gz file, which can go up to 1 giga or even more. And then you upload this, and you get your model on DAFNI. And just to give also a glimpse of what does a DAFNI configuration looks like. You see it's really well structured, and you need to specify all the inputs of your model, all the outputs. So first of all, of course, you get some metadata that you can provide, information and so on, and then the specification. So the inputs, I've got some parameters. So the name of the functional urban area, so these are some modes for the population, the sample parameter that I mentioned, some then runtime parameter like the memory, and then you also specify the dataset you need. So this dataset, you have already uploaded them on DAFNI, and you've got them on DAFNI, or you can use other dataset that some users have uploaded on DAFNI. So it's quite powerful to handle the dataset this way. You just give some ID that DAFNI provides you. So if I go back into DAFNI, I go into data, and if I click on any, okay, this is output data, but okay, I think because then if you run a model, it produces here. You can get this ID and put it in your config file, and it will give you this particular model data and this particular version. I think I need to speed up because of time, and so on. And you see all the data set here. It's for the configuration of the MATSim population file, but then you can have the MATSim file is similar, and so on. You got all your parameters. And let me just show you quickly the MATSim workflow and the MATSim model here is here. You've got the parameters. Okay, so it's weird that there's no data set here. No, it's normal for the MATSim model. You've got no input because you pipe all the XML files. And then from the model, you can build a workflow. So the workflow is coupling your different models. So this is a MATSim full workflow. And if I do edit it, so you got some metadata. Let's say I do a new version, and you see it look like this. So Brian showed different workflows. Starting, first you generate your synthetic population, then you process your network, and then you run the MATSim model on it. And in the end, you've got the visualization step. And I think I will just have a bit of time to show you the visualization, what it looks like. Can I change tab here? No, I can't. Ah, yes. So this is a Jupyter notebook embedding into DAFNI. And here it's visualizing the synthetic population. I didn't have time. Oh, I didn't have time to do some visualization for MATSim, but only for the population part. But for example, here you can see population.ct on this. I think it's staying. Okay. Population.ct on this map. And then some flows, home workflows for the same urban area of Exeter. So this looks like this. Let me go back quickly to the slide. Another integration is into OpenMOLE. And you see that I will show you now some scripts. And you see that it's quite similar. You have an OpenMOLE here. So you've got this GUI, but here you don't have a visual workflow, but you've got some scripting language. So I think Romain will tell you more about this a lot. So you define your model as tasks. So a container task is a Docker task, but you have other languages and you can do any language task. And you specify your parameters and so on. So here you have a population, MATSim, then some output processing. And in the end, your workflow is here. My model is configuration, then population, then release some network file, then MATSim, and then output processing. You see that you've got this language, high-level language to define your workflow. And then I can run my method by specifying here it's CellTally global identifier this. I just specify this and it will run the thing. So it's really two different ways of doing the thing, but it's actually quite similar. And yeah, what I did not mention is that you can, if you want, also integrate OpenMOLE into DAFNI by putting OpenMOLE itself into a Docker, then putting it on DAFNI as a Docker container. So maybe we'll be working in the future to have a stronger integration, but for now you have to do it this way. Okay, I think I'm just a bit of time, so it goes very fast for the result. But on preliminary results, because yeah, we have still issue with memories, with runtime and so on. It's quite difficult, but we have still preliminary results. So looking at the role of randomness stochasticity, there is quite a strong impact, and you can end on quite different results. For example, here looking at the distribution of trips times after you have converged with the MATSim model. So it seems that there are two different attractors for this specific area, and you can converge over one or the other one. And then looking at results for global analysis, so I won't detail this, but these are indexes to quantify the influence of one variable, so one parameter, on some model outputs. So you can look at the first order or total order, looking at interaction between variables. And we obtain this with quite a small number of ones, so I wouldn't be that confident into the robustness of this result. We still need more, so these are really preliminary. But we quantify, for example, the influence of discrete choice parameter. No, it's not really discrete choice, but mode choice parameters into the mode shares. And it's quite surprising that we don't have any influence. So it's very low of this parameter. So I have to dig a bit into more on why is this. I think I have some clues because it's only the constant in the scoring, and I have to modify other parts. But and you see, for example, also here the S is the random seed. So stochasticity has a strong influence of the mode share. And then also the area has quite, if you change the area, you will have quite a small influence, but non-negligible on the different mode shares, and a strong influence on the average shape distance, for example. So it's quite, so we need to run more, but it's quite interesting. And I think it's one of the first time we such analysis are run on the MATSim model. I will skip the discussion because yeah, the purpose was more to demonstrate and to show you. But yeah, there are some questions and issues that we can keep for discussion of what is the role of visualization, for example, and also for reproducibility. If you need a lot of memory, so someone who doesn't have access to DAFNI, he won't be able to do the same. So is it really reproducible? And there are also a lot of future development similar to this. Okay, so I conclude here, and I will hand over for the more detailed demo of DAFNI by Tom. So everything in, I think you will get the slide on the video later, but everything is open source on this repository. Thank you.